Hi guys, and welcome to a physics series. Today we have a Specimen paper 2 2020, question 32. The diagram shows part of an electrical circuit and the current in the 4 ohm resistor is 3 ampere, and what is the electric current in the ammeter. Now we highlight some keywords: electrical circuit, current, and 4 ohm as a value of resistor, and 3 ampere, which is the value of the electric current, and current and ammeter. Shown in the diagram, the electric current, which is 3 ampere, passes through the 4 ohm resistor in the first branch. So the value of the electric current, which is 3 ampere, and the value of resistance, which is 4 ohm. Find out the relation between the electric current and the resistor. So to calculate the applied voltage across the 4 ohm resistor using Ohm's law. Ohm's law, which is V as voltage equals to I for the electric current times the resistance. The value of the electric current, which is 3 ampere, and times the value of resistance, which is 4 ohm, the magnitude of the voltage, which is 12 volt. Remember that we highlight electrical circuit, and in the circuit we have it's a parallel circuit because both resistor they are connected in parallel, and in addition that we have two branches as shown in front of you. The first one has a 3 ampere and the second one it's a known value of the electric current. One of the advantages of parallel circuit, in this case both resistor have the same applied voltage. It means if the applied voltage across the resistor, which is 4 ohm, and the first branch, which is 12. Now we are going to use the value of the voltage, which is 12 volts, and the resistor, which is symbolized by the R, is 2 ohm, and the only unknown, which is the electric current, which passes through the branch or the second branch, which is the 2 ohm. So the value of the electric current here, which is the unknown. To calculate the current in the branch 2, we have to rearrange the Ohm's law formula. So I equals to the V divided by the R. The value of the voltage, which is 12, divided by the value of resistance, which is 2.0 ohm. So 12 divided by 2, which is 6.0 ampere. So the value of the electric current in the branch 2, which is 6.0 ampere. Finally, to calculate the current passed through the ammeter, and this is the total current IT, which is splits up at the point which is junction into two currents. First one, which is 3 ampere, and the second one is 6 ampere. So the I total is 3 plus 6, which is 9 ampere. So the correct answer is C. By the end of the video, please don't forget to share and like and subscribe. Thank you.